Okay, we will continue from the previous video where we have discussed about the scalar and vectors and vector addition. We completed this vector addition, how to find out the resultant vector value if the two vector is having some angle theta, and we'll discuss some example in this section. Suppose if you are having we will consider some real life situation in vector addition. So if you consider the case, suppose a person is in the middle of a river, and the river is having water which is flowing with in this direction. Let's say the velocity of the water is 3 meter per second. So let's say this is 3 meter per second, and the direction is from like this. So we have both direction and magnitude, so it is a vector. It is simply velocity. So velocity of the water which is flowing in the river, so which is 3 meter per second. And if this person is at rest in the middle of the water, maybe he is using some boat or something, let's assume, then it is we can say if he is in rest, then this person also will move because of the velocity of the stream. This person also will move with 3 meter per second velocity, and the direction will be the same as the water flow. Now if you consider the case when you are having so we have to consider one important fact here. We can classify the vectors differently, and if the person is at rest, which means that he is not having any magnitude, but if you want to add it with other vector, then it should be another vector. Okay, so there is also some vector called zero vector, so you can also search for that. It is also interesting because there are different classification of vectors. Okay, anyway, we will discuss something else here. Okay, so let's consider another example. For example, this person is at the middle of the river, and the river is flowing with, as said previously, 3 meter per second velocity. And then suppose this person is swimming against this river flow or water flow, and if he is having the 3 meter per second, same 3 meter per second of velocity, but in opposite direction. Okay, now what will happen by using your vector addition? Suppose if you consider the triangular law of vector addition, then what we have suppose this is in red color. We have this vector with 3 meter per second of magnitude in this direction. This is representing the velocity of the water stream, water which is flowing through the river. And the second case is that we have the vector which is the velocity of the person who is swimming against this direction of the flow of water. Now these two are opposite in direction, so if you use these two velocities, they are vectors, and if you add these two, now we can understand, in order to add these two, you have to place the tail of the second vector on the top on the head of the first vector. Okay, so if you assume a situation like that, then we can clearly see the angle between these two vectors will be 0. The angle between these two vectors will be 180, because when you place this over the other vector, okay, then this angle becomes 180 degree. We can represent it like this. it will be like this, and the first vector will be here. Okay, so the angle if you measure between A and B, which will be like this, so it will be 90 degree, it will be 180 degree, sorry, it will be 180 degree. So the angle here is 180 degree. Now if you substitute that in your equation for C, then what we can observe, C will be equal to, both your magnitudes are same, so we can say A equal to B. Then we have A square, well, let's say there will be A square plus B square, so then we can say it is 2 times A square. Okay, then we have plus 2 times A into B into cos theta, so it is plus 2 times A into B means nothing but A square. Okay, and cos theta is cos 180, cos 180 is minus 1. So if you add these two, this becomes 0. So which means that the magnitude of the resultant vector is 0. In other words, this person will be at rest. Okay, if he is applying same force against the water stream. And in third case, if you consider a person is crossing this river like this, and this river is having as previously said 3 meter per second velocity, and the person who is crossing this stream is having 4 meter per second velocity, let's say, then the resultant will be by using this parallelogram method, we can say this will be the resultant vector will be from this to here. So this will be the resultant vector, right? So the direction, you can see the direction, the person is actually trying to reach from this point to this point, but is because of the flow he will be reaching at this portion of the river. So the direction is different, which is not the direction of the person who is swimming, and it is not the direction of the flow, but it is a direction different from both these. So when you are calculating by using a vector, so the resultant will be dependent on the direction of the initial vectors. And similarly, you can find what is the magnitude of this vector by using the previous equation. So in this case, you will be having this, suppose this is your B and this is your A, let's say, then you will be having this also will be your B, magnitude B, and this is your A. Then you can use C square equal to B square plus A square, and theta will be 90 degree here, because the angle between this A and B will be 90 degree, so cos 90 will become 1. Okay, cos 90 becomes 0, and you will be having C square equal to B square plus A square. This is simply the Pythagoras principle. So you can calculate what is the magnitude of this vector also. That means how much speed he is having with at this situation. But he will be reaching at different point. If he want to reach at the same point, for example here, okay, so let's consider this case. So if you want to reach at the exact point here, then what he has to do, this stream is having this much of 3 meter per second velocity in this direction, and the person has to move swim like this. Okay, the person has to swim like this, and he will be, if he is swimming like this, then we can use the Pythagoras principle. Then you will get the parallelogram like this, and he can reach at this position. So you can start from here. So in such case, if you want to reach at the same line, then he has to move a little upward like this. He had to swim little upward. So this is a basic some real life situation where you can apply the vector addition and how it is changing things. So I hope you understood this.